Hello and welcome to GeoMind. Today we are starting the lecture on glacial landforms. Glacial landforms is a part of the subject known as geomorphology. Geomorphology is a subject which is related to both geography and geology. Now this subject is very important. Most of the time the questions are asked from the landforms, and glacial landforms is one of the topics which is very important when it is related to the examinations such as UPSC prelims, be it civil services or geological sciences, GATE, Geology, CSIR or UGC net examination, and many other state PCS, IIT JAM examination. Okay, so we will be looking at the erosional landforms today, and we will discuss these landforms. My name is Swapnil, and if you haven't subscribed to the channel, don't forget to like, share and subscribe to GeoMind, and you can join my Telegram group. I have given the link in the description below. So let's start with some introduction to glaciers. Okay, so as you know, glacier is what? Glacier is a moving mass of ice. Okay, and the landforms which it creates are known as glacial landforms. So one word comes to mind is your cryosphere. Okay, so cryosphere is basically that region of the earth where there is ice and snow. Okay, similar to atmosphere. Like an atmosphere is that region of the earth which contains air, that is atmos. So similar to that, the region of the earth where your ice and snow is there, okay, is known as cryosphere. So cryosphere consists of the ice in rivers, oceans, on the land and under it. Okay, so if you can see in this image right now, this is the peak glaciation that happened 19,500 years ago, and you can see that North Pole and South Pole. Okay, North Pole and South Pole have extensive ice sheets present in them, and there are some alpine glaciers, okay, in some continents, but most of the ice is present in your ice sheets. But if you look at the present day, unfortunately the ice has shrunken very much. So this is the North Pole now, and this is the South Pole. Okay, so climate change is real, guys, and we are just moving towards a warmer earth, and currently we are living in interglacial period. Okay, interglacial period. Interglacial period is that period of the earth where warming is happening. This is just an example of the ice sheet that is covering the South Pole, that is Antarctica. Okay, you know the Antarctica is a continent, and over that you have this wide ice sheet which is also known as Continental Ice Sheet. And you can see that ice sheet is almost 1 to 2 kilometers thick, but this itself is being shrunken at very rapid rate. Okay, one of the region is very famous here, that is Ross ice shelf. Okay, it's a very big chunk of ice sheet that is receding rapidly due to global warming. Okay, so moving on, this was just an introduction to your cryosphere, and here you can see in this chart there is glacial period, that is 19,500 years ago. The last glacial maximum happened, and currently that is in this is the time period. Okay, so we are living at zero time period right now. So currently the earth is experiencing a warmer climate. Okay, and we are living in interglacial periods. All right, so yes, there has been some glacial interglacial periods, warmer periods, but most of the people argue that this is just a natural cycle that is happening. But the anthropogenic CO2 which is being released by human on the earth is just acting as a catalyst to this process. So again, I'm saying that climate change is very real. Now, if you talk about the causes of ice ages, we know that there are two main causes: plate tectonics and variation in Earth's orbit. This is very important. This is known as Melancholic Cycle. Okay, Milankovic was a Serbian astrophysicist. His full name was Milutin Milankovic. All right, and you know that plate tectonics causes the ice ages, because if you look at the Earth around 510 million years ago, that is in Ordovician period, Cambrian period, you can see that Earth was the continents were arranged in this fashion. So most of the landmass was in South Pole, and obviously you will have a greater number of ice sheets present here. So this is the one reason which causes the glacial maximum or interglacial period on the Earth. Coming to the main topic, that is your Milankovic cycle. Milankovic cycles are basically changes in the Earth's orbit, or shape of the Earth's orbit, or changes in the obliquity, that is the angle of the Earth's axis. Okay, due to that the Earth receive different rate of radiation on the radiation of the sun on the Earth, and due to that you have your climate change. The wobbling of the Earth's axis is also one of the factors which is responsible for the climate change. Okay, because in turn climate change is what? The amount of radiation received by the Earth. Okay, so if you talk about the Bilancovic cycle, the climate is changing due to the variation in the amount of sun's radiation that is received by the Earth, and it is caused by changes in the shape of the Earth's orbit, changes in the obliquity of the Earth's axis, and wobbling of the Earth's axis, which is also known as precession. Okay, so here you can see the sun and you have the Earth. Okay, its orbit is like this, and the orbit can change its shape over time for about in 1 lakh years. Okay, that is 100,000 years, and due to that Earths receive different rate of radiation. Similarly, you can see that the axis of the Earth is here, and it changes its degree, that is angle, slightly over 41,000 years. Okay, over the course of 41,000 years, and it can change from 21.5 degrees to 24.5 degrees, and due to that also the Earth receives different rate of radiation, and climate can change due to that. Okay, so maximum tilt is 24.5 degrees, minimum tilt is 21.5 degrees. Okay, and currently we are in 23.5 degrees. Okay, so this is the angle of the Earth's rotational axis. Similarly, Earth's axis also precess. Okay, like most of you might have played this top, which is a toy, and when this is rotating, this toy is rotating, its axis is also rotating. Okay, so this rotation of the axis is known as precession. So this precession is also changes its position. 26,000 years is the course of time through which it changes its position. Okay, so currently you are seeing North Star. If you are standing in the North Pole, you see the North Star, axis is pointing toward the North Star, but through 26,000 years you will see the Vega. Okay, so currently the North Star is Polaris, right? The name of the North Star is Polaris, but after 26,000 years, 26,000 years, your North Star will be known as Vega. Okay, because the axis will be present here. Okay, so this is also causing the Earth to receive different rate of radiation, and in turn causing the climate change. Okay, so this was something about your glacial maximum, glacial minimum, and your cryosphere. Now we will talk about the ice itself. Okay, so there is loose snow. Okay, the fresh snow is known as loose snow, which has pores present in it. and pores are almost 90% air. Okay, so the loose ice is almost 90% air. That's why your foot just sinks deep into the fresh ice. But over the course of time, this fresh snow will be compacted. Okay, where the pore spaces will only have 50% air. Okay, 50% air. Then over 10,000 years, this granular snow will be turned into firn. Okay, so this term is important. This is sorry, it is known as firn. Okay, firn. So this is the ice is very compacted due to pressure because of the time period, and in this firn, which is a type of snow, compacted snow, very old snow, it only has 25% air. Okay, and then again over 1 lakh years, the ice is completely compacted and the air is only less than 20%. Okay, and the grain size becomes, the ice also has crystal, right? The ice has crystal structure in it like this. This is the typical hexagonal shaped crystal structure of the ice, and it becomes, when it is compacted through lakhs of years, the ice becomes coarse grained. Okay, so the terminologies you have to remember that, like firn. What is firn? Okay, so firn is very old ice which has been compacted about 1 lakh years. Okay, so coming to the glacial landforms, glacier is what? A moving mass of ice, okay, averaging few meters a day. So this you see here, this is like a road or a river which is flowing. Okay, so this is a very huge mass of ice. It's a type of valley glacier which is present in this valley. Okay, तो जब ये ग्लेशियर मूव करता है तो लैंड को कार्व आउट करता है. ओके, सो इट डिफॉर्म्स द लैंड एंड देन द लैंडफॉर्म्स व्हिच इज क्रिएटेड आर नोन एज glacial landforms. So if we talk about the type of glaciers, you can see that there are 3 main type of glaciers. First important is your mountain glacier. Okay, mountain glaciers are obviously will be present in your high altitude mountains, also known as alpine glaciers. Alpine glaciers. Okay, now when this glacier is present at the foot of the mountain, okay, आपको दिख रहा है ये mountain है, this is the mountain, and it is like a fan, right, an alluvial fan. So similar to that, this glacier, when it reaches to the foot of the mountain, at the base of the mountain, it just expand like a pancake. Okay, so this type of glacier is known as Piedmont glacier. Okay, Piedmont का मतलब ये होता है present at the foot. Okay, then there is valley glacier, is a type of mountain glacier which is present in the valley, and then there is a cirque glacier, is also a type of glacier which is present in a bowl shaped landform. Okay, bowl shaped, this. Okay, so this is known as cirque glacier. So this is an example of Piedmont glacier. Malaspina glacier in Alaska. Okay, so these are the mountains, and when this valley glacier just expand at the foot of the mountain, it becomes a type of Piedmont glacier. Okay, then there are other glaciers which are known as Continental Glacier or Continental Ice Sheets. These are basically the glaciers which are present at the South Pole and the North Pole. Okay, these are very vast sheet of ice which is covering the land, or sometimes it is also covering the ocean, but we are concerned with the landforms, so we will talk about South Pole, okay, or Greenland. Okay, so Continental Ice Sheets. Okay, these are very large sheets of ice which are present generally at the North Pole and the South Pole. So in winter you can see that this is the Arctic Ocean. तो यहाँ पे क्योंकि ओशन है, ओशन फ्रीज हो रखा है, तो यहाँ पे लैंडफॉर्म तो होगा नहीं, लेकिन कॉन्टिनेंटल आइस शीट्स जनरली जैसे ग्रीनलैंड है, तो ग्रीनलैंड क्या है, एक तरीके का लैंड मास है, उसके ऊपर आइस है. ठीक है, तो यहाँ पे हम कॉन्टिनेंटल आइस शीट इसको हम बोलेंगे. ओके, दिस इज ऑल्सो अ टाइप ऑफ आइस शीट बट इज नॉट कॉन्टिनेंटल. देन दिस इज द साउथ पोल. साउथ पोल में पूरा का पूरा अंटार्कटिका आप देख सकते हो कवर है. ओके, कॉन्टिनेंटल ग्लेशियर्स। तो ग्लेशियर जो यहाँ पे प्रेजेंट होंगे उनको हम बोलते हैं कॉन्टिनेंटल glacier. Okay, so here you can see the ice sheet in the Greenland, which is almost 2 kilometers thick. Okay, 2 kilometer thick. Then in also Iceland, this is a huge huge ice sheet in the Iceland, which is known as Vatnajökull ice cap. Okay, so two main type of glaciers, alpine glaciers and continental ice sheet. Alpine glacier के अंदर आपके Cirque glacier, Valley glacier and here Piedmont glacier. Okay, so this is the Antarctic ice sheet. You can see कितनी thick है. Okay, and Greenland ice sheet, or this is the landmass which is present beneath the ice sheet. Okay, so as you can see, the ice sheet sometimes just carve out these icebergs, okay, due to global warming. So iceberg is almost 90% it is hidden beneath the ocean. Okay, so this is known as iceberg, pretty common. टाइटैनिक आपने सबने देखी होगी. अगर हम सोलर सिस्टम की बात करें तो सोलर सिस्टम में सबसे नजदीक का जो प्लैनेट है हमारा मार्स पे भी आपकी पोलर आइस कैप्स हैं. ओके, polar ice caps, right? So this you can see, this is present in the north pole of the Mars. Okay, and आपको पता होगा कि in future humanity may terraform this planet, and the most common proposal is that how we are going to terraform is by nuking these ice caps. Okay, nuking का मतलब होता है कि when we are going to just bomb away these ice sheets, just nuclear bomb away these ice sheets, and this will call a global warming type of phenomena, and by this we can generate an atmosphere in this planet. Okay, so this was proposed by Elon Musk and other scientists. Now if you talk about the movement of the glacier, the first and foremost thing you have to remember is that the movement is generally plasticky in nature. Okay, so this is a glacier. Okay, this is white and it's like a cuboid form here. So in the middle of the part, glacier is moving plastically. Okay, plastically. Over the top, this is brittle. Okay, brittle in nature. So due to this its brittleness, at the top of the glacier, it is also known as zone of fracture, और यहाँ पे आपको crevasses भी बहुत देखने को मिलेंगे. Okay, crevasses. So crevasses are basically these deep fractures which are present at the top of the glacier. Okay, and at the base the ice is basically sliding due to the friction which is caused by this huge ice mass. Okay, and friction, आपको पता है friction is causing heat. Friction causes heat, and due to the heat, the lower part of the glacier also melts, and when it melts it will cause less friction and it will slide. Okay, but the maximum movement is at the top. Okay, and basal sliding is also there, but is the slip is basically being resisted by this bedrock. Okay, so maximum travel will be in the middle. Okay, at the center of the glacier. Okay, center of the glacier. Okay, so plastic flow is just almost in the middle of the glacier. Okay, basal slip will be at the base. Okay, basal slip will be at the base. Due to the friction, the layer of water is there and it acts as a lubricant. Okay, and that's why the glacier moves. Okay, so you can say that the glacier is actually skating down the bedrock. Okay, and if you talk about the continental glacier में क्या होता है कि due to its shape, क्योंकि ये एक शीट की तरह होता है, तो it flows फ्रॉम ऑल डायरेक्शन लाइक अ पैनकेक। जैसे आप पैनकेक बनाते हो, पैनकेक बना के आप क्या करते हो कि like this is the pan, okay, like this. So you put the batter in the middle and then it flows towards the all direction from the top. Okay, so this is the movement of the continental glacier. Okay, now if we talk about the zone of accumulation, ablation, basically the accumulation is that zone where the snowfall is turning into ice. Okay, so it will obviously be at the higher altitude. Okay, then the zone of ablation. Ablation is basically means where the glacier is receding. Okay, रिसीडिंग यानी कि कम हो रहा है, तो ऑब्वियसली ग्लेशियर कहां पे रिसीड होगा, लोअर एल्टीट्यूड पे रिसीड होगा। ठीक है, इवेपोरेट होगा, सबलिमेशन होगा आइस का, ग्लेशियर कार्विंग होगी, तो वो जोन जहां पे ग्लेशियर रिसीड हो रहा है, दैट जोन इज नोन एज जोन ऑफ एबलेशन। ओके, सो if the ablation is more than the accumulation, then the glacier will recede. Okay, like it is happening in the Indian region, in the Himalayan region. You can see that Gangotri glacier and all these glaciers are basically receding. It means that ablation is happening, and ablation के phenomena क्यों होता है ablation? Global warming, right, is the main root cause which is causing the glacier to melt away, okay, or recede away. Okay, आइस उतनी बन नहीं रही है और यहाँ से ग्लेशियर रिसीड हो रहा है, तो ये इसका जो फ्रंट है, इट विल बी समवेयर हियर in some time. Okay, and if glacier advances, it means that ice or the snowfall is very high, and due to that glacier is advancing and ablation is low. Okay, and line of equilibrium is when there is accumulation is equal to ablation. All right, so these terms you have to remember. Okay, so this is how we measure the advancement or receding of the glacier. We basically put poles. Okay, छोटे छोटे डंडे होते हैं ऐसे. These poles are put on the glacier, at the top of the glacier, and as you know, the glacier is moving maximum in the middle. These poles will have shapes like these. Okay, तो इस तरीके से हम पता कर सकते हैं कि ग्लेशियर कैसे मूव कर रहा है, उनकी पोजीशन, ग्लेशियर की पोजीशन, ओके, कितना ये आगे बढ़ा है, ओके, बढ़ा है या पीछे हुआ है। If we talk about the India, you can see that most of the alpine glacier are there in India. इंडिया में continental glacier नहीं है, okay, and these are some of the important mountain ranges. Karakoram is at the top, then Ladakh, Zanskar, ये basically UPSC में पूछा जाता है, okay, कि नॉर्थ से लेके साउथ तक की सक्सेशन बताइए, तो कराकोरम, लद्दाख, जांस्कर, पीर पंजाल, धौलाधार, ओके, बिटवीन द जांस्कर एंड पीर पंजाल you have great Himalayan range, okay, and then at the base you have your Shivalik hills. So this is basically from the north to south. So this succession is very important if you are preparing for the UPSC. Now we will talk about the main topic, that is glacial erosional landforms. Okay, तो इरोजनल लैंडफॉर्म्स आपको पता है कि इरोजन के कारण होता है, ग्लेशियर जब लैंड मास को क्या करता है, इरोड करता है, ओके, इरोड करता है. सो सम लैंडफॉर्म्स आर प्रीटी बेसिक हियर, ओके, नाम से पता चल रहा है, लेकिन कुछ इंपॉर्टेंट है, जैसे फ्योर्ड. फ्योर्ड बेसिकली एक क्या होती है, वैली होती है, ओके, लाइक दिस, ओके. नॉर्वे या स्वीडन या जितनी भी स्कैंडिनेवियन कंट्रीज हैं, वहां पे आपको ये वैलीज देखने को मिलेंगे, विच आर बेसिकली मीटिंग द वाटर बॉडी वैली. सो दीज वैलीज वर कार्व्ड आउट बाय ग्लेशियर्स. ठीक है, ये जो वैलीज हैं जहां पे अभी आपको पानी दिख रहा है, दीज वर कार्व्ड आउट बाय ग्लेशियर. ओके, सो फ्योर्ड आपको ध्यान में रखना है. फ्योर्ड क्या है, बेसिकली वैलीज हैं विच बेसिकली मीट द सीज और अ वाटर बॉडी, ओके, एंड दीज वैलीज वर कार्व्ड आउट बाय ग्लेशियर. काफी ज्यादा डीप वैलीज ये होती हैं, इनसाइज रहती हैं, ओके. सो फ्योर्ड आपको ध्यान में रखना है, ओके. ग्लेशियल ट्रफ और अ वैली, ओके, विच is below the sea level, the floor of which is below the sea level, and often U-shape. Now you have to remember that the valleys which are carved out by glaciers are often U-shaped. Okay, अगर आप सामने से इसको देखोगे तो ये U-shaped का होगा, और अगर कहीं पे आपको V-shaped की वैली दिखती है तो V-shaped valley is basically formed by the river. Okay, river. Then hanging valleys are also a type of glacial landform. तो hanging valley basically आपने पढ़ा होगा. Hanging valley में क्या होता है? That you have a main glacier, ठीक है? Sorry. That you have a main valley glacier, और यहाँ पे कोई पहाड़ है और यहाँ पे भी एक तरीके का वैली है, ठीक है, और ये ग्लेशियर यहाँ पे मिल रहा है, तो इसको हम बोलेंगे hanging valley. Okay, so hanging valley is basically also carved out by the erosion by glacier. Okay, then there is whaleback or rock drumlin. Okay, so whaleback or rock drumlin, इसको भी हम देखेंगे. Okay, so this is known as whaleback, या इसको हम रॉकी माउंटेन भी बोलते हैं. ओके, ओके, so Rocky Mountain, whaleback or rock drumlin is similar in fashion. Okay, so we will talk about Rocky Mountain है. Okay, बाकी यहाँ पे important forms नहीं है, तो okay, so these names you have to remember. Just Rigel. Okay, ये क्वेश्चन पूछा नहीं जाता है, बट क्योंकि सारे को लगभग पूछे गए हैं तो ये पूछा जा सकता है. ओके, Rigel. ओके, लो रॉक रिज, स्टेप और बैरियर लाइंग अक्रॉस अ ग्लेशियर. ठीक है, दिस इज अ टाइप ऑफ रिज. ओके, रिज लाइक माउंटेन रिज. ओके, देन सर्क, कोल, रॉकी माउंटेन. ओके, दिस इज इंपॉर्टेंट. फ्लिकबर्ग, क्रैग एंड टेल, तो इसके बारे में हम पढ़ेंगे. ये सारे के सारे लैंडफॉर्म में इंपॉर्टेंट है. ओके, देन एरेटे, हॉर्न, नुनाटाक. ओके, चैटरमार्क, क्रिसेंटिक फ्रैक्चर, these we will discuss currently. So चैटरमार्क are basically these striations. ठीक है, ये आपको दिख रहा है ऐसे क्रिसेंटिक शेप के जो आपको बेड रॉक पे देखने को मिलेंगे ड्यू टू मूवमेंट ऑफ द ग्लेशियर. These are known as चैटरमार्क्स. स्ट्राइएशन भी कुछ इस तरीके की पॉलिश्ड सरफेस जो रहती है एक लीनियर फैशन में, उनको हम बोलते हैं. तो स्ट्राइएशंस, चैटरमार्क्स, बेसिकली दीज आर कॉज्ड बाय अगेन ग्लेशियर मूवमेंट. दीज आर स्ट्रीमलाइन फॉर्म्स. ओके, सो दिस इज अ रॉकी माउंटेन. ओके, रॉकी माउंटेन बेसिकली क्या होता है, ये आपका ग्लेशियर है. सो दिस इज योर ग्लेशियर एंड ग्लेशियर इज मूविंग टुवर्ड्स दिस साइड. ओके, एंड इट इज कॉजिंग द rock, bedrock to erode and form in this fashion. ठीक है, so the tail is here, okay, and head is here. Okay, so you can say that lee and stoss side. Okay, so basically this is causing the erosion of this bedrock, okay, in this fashion. So you will get this type of, so here you will have glacial plucking. ओके, यहाँ पे फ्रैक्चर्स वगैरह रहेगा और यहाँ पे स्मूथ रहेगा. ओके, सो लार्ज रॉकी माउंटेन्स विच आर बेसिकली मोर देन 1 किलोमीटर इन साइज, जिनका साइज 1 किलोमीटर से ज्यादा रहता है, उनको हम बोलते हैं फ्लिकबर्ग. ओके, फ्लिकबर्ग. All right, Flickberg, this one. So Rocky Mountain will be 100 meter, mostly 100 meters or 200 meters. Okay, so stoss side is abraded, polished and sloping, जो मैं आपको बता रहा था. Okay, this is stoss and this is lee side. ठीक है, ये जो steep वाली साइड है इसको हम बोलते हैं lee, और ये वाली जो साइड है इसको हम बोलते हैं स्टॉस. ओके, सो दिस इज स्मूथ, पॉलिश्ड, एंड ली साइड इज टुवर्ड्स द downwind side. Okay, this is the upside, okay, in the up direction, okay, and this is the down direction of the glacier. Okay, so lee side is basically fractured and stoss side is basically smooth and polished due to the movement of the glacier. Okay, and if this is more than 1 kilometer in length, then this rocky mountain is known as Flickberg. Okay, Flickberg. Then there is crag and tail. Okay, crag and tail में basically क्या होता है कि if there is a resistant rock in between, okay, this rock, let's say ये जो काली रॉक जो आपको दिख रही है, ये लेट्स से कि बहुत ही रेजिस्टेंट रॉक है, एक तरीके का इग्नियस इंट्रूजन है. आपको पता है इग्नियस रॉक जो रहती हैं काफी हार्ड रहती हैं. ऑलराइट, एंड ग्लेशियर इज मूविंग लाइक दिस. तो ये क्या करेगा, जो सॉफ्ट रॉक है, सेडिमेंट्री रॉक्स है, इनको इरोड कर देगा. द ग्लेशियर विल इरोड अवे दीज सेडिमेंट्री रॉक्स एंड देन इट विल एनकाउंटर अ रेजिस्टेंट रॉक. ओके, एंड दिस रेजिस्टेंट रॉक विल नॉट बी इरोडेड अवे. सो दिस विल फॉर्म अ क्रैग एंड टेल feature. Again, this is similar to like Rocky Mountain, but here we have a resistant rock. Okay, so like this. So in this case, the lee side is what? The up direction side. Okay, so this is the lee. Okay, and this is the stoss. So crag and tail. Crag, ये जो resistant rock जो यहाँ पे, इसको हम बोलते हैं crag. Okay, and tail. So crag and tail is also a type of erosional feature. Okay, now we will move on to horn arete. So this is a very important diagram. जिन्होंने CSIR नेट एग्जामिनेशन दिया होगा उनको ये अच्छे से पता होगा. इसमें काफी ज्यादा बच्चे कंफ्यूज भी हो गए थे, तो इसको हम देखते हैं. ओके, तो arete. So arete is basically a very sharp ridge. Okay, बहुत ही sharp ridge होती है जिसको हम बोलते हैं arete. Ridge basically क्या होती है, when there is a mountain, okay, and there is a sloping side on both of the sides. Okay, एक side तो ये होगी और एक इसके पीछे होगी, right? तो similar to ये भी एक तरीके का arete है ये वाला. ठीक है, ये जो शार्प रिजेस होती हैं, which is being created by these cirque glacier, eroding of this cirque glacier, it is known as arete. Okay, then there is horn. So horn is basically when the shape of this ridge is like pyramid shape. पिरामिड शेप. तो एक हॉर्न शेप का जब आपको कहीं पे फीचर मिलेगा, बेसिकली हॉर्न पीक्स होती हैं. ओके, माउंटेन पीक्स होती हैं विच इज कॉज्ड बाय द इरोजन ऑफ 2 और 3 ग्लेशियर्स. ओके, जनरली 3 सर ग्लेशियर, 1, 2 और तीसरा इधर की साइड से होगा पीछे से. तो ये इरोड करेगा, माउंटेन को इरोड करता रहेगा और एक शार्प पीक बना देगा. ओके, इसको हम बोलते हैं हॉर्न. और एरेटेज आर बेसिकली नाइफ लाइक रिजेस. ओके, तो हॉर्न और एरेटे में क्या डिफरेंस है? एरेटे नाइफ लाइक रिजेस होती हैं, बेसिकली 2 शर्क ग्लेशियर जब इरोड होते हैं, इरोड करते हैं, सो एरेटे बनाते हैं. एंड व्हेन देयर आर 3 सर्क ग्लेशियर इरोडिंग द माउंटेन, इट विल फॉर्म अ सिंगल पीक नोन एज हॉर्न. तो एरेटेज आर बेसिकली रिजेस. ओके, हॉर्न आर बेसिकली पीक्स. ओके, सो हियर यू कैन सी ये आपका पीक है. This is basically a peak and aretes are basically these ridges. Okay, और ये सर्क है बीच में एक बोल शेप का फॉर्मेशन. ओके, इसको हम बोलते हैं सर्क. ओके, बोल शेप, जैसा कटोरा होता है ना, उस तरीके से. सो सर्क, arete, horn, these are all glacial erosional feature. Okay, and sometimes when this सर्क the ice has been receded, okay, it will get filled with water and it will form a lake which is known as tarn. Okay, so tarn is basically a cirque lake. All right, cirque lake. Then there is truncated spur. Okay, truncated spur. So base पे when there is a mountain ridge which is basically eroded away. Okay, This is known as truncated spur. Alright. So arete हमने डिस्कस कर लिया. Narrow sharp edge ridge separating two cirques. Horn peak formed by intersecting walls of 3 or more cirques. ठीक है, ये भी हमने देख लिया. एंड नुनातक बेसिकली क्या होता है? When there is an unglacious island of bedrock, okay, surrounded by ice. तो इसको हम देख लेते हैं. Okay, these we have discussed. Okay, so this is an example of horn, Matterhorn in Switzerland. Swiss Alps is very famous peak. Okay, highest peak in Alps, the Matterhorn is a type of, नाम से पता चल रहा है एक हॉर्न है. ठीक है, पिरामिड शेप का. Okay, so this is a glaciated U-shaped valley. Okay, this is known as Glacial Trough. And P forms basically these molded, plastically molded striations which are caused by the erosion. Okay, तो ये आपको ध्यान में रखना है, P forms. Okay, and when this erosion is caused by melt water origin, then it is known as S form. यानी कि पानी की वजह से अगर कोई erosion होगा, okay, तो इसको हम S form बोलेंगे. And if this is caused by the glacier, it is known as P form. Okay, so Nunatak are basically what? The mountain peaks which are unglaciated. यहाँ पे कोई आइस नहीं है ना, नो आइस, लेकिन चारों तरफ आइस ही आइस है, बर्फ ही बर्फ है. तो बेसिकली ये एक आइलैंड की तरह दिखते हैं. ओके, दीज पीक्स आर देयर एंड चारों तरफ बर्फ ही बर्फ है, तो इसको हम बोलते हैं नुनाताक. ओके, नुनाताक. सो दिस इज अ वेरी इंपॉर्टेंट चार्ट. ये इसमें बता रहा है कि जो लीनियर डायमेंशंस हैं, दीज आर हाउ मच. ओके, दिस यू कैन फाइंड इन ग्लोबल जियोमॉर्फोलॉजी बाय समरफील्ड. ओके, ये सारे हमने डिस्कस कर लिए हैं. ऑलराइट, सो दिस वाज ऑल अबाउट ग्लेशियर लैंडफॉर्म्स. ठीक है, इस वाले चार्ट में आप देख सकते हो कि जैसे एरिटेज, हॉर्न्स, नुनाताक, इनका लीनियर डायमेंशन कितना होता है? 1 किलोमीटर के आसपास. ठीक है, Rocky Mountains are 100 meters, okay, till 100 meters, and 1 kilometer के बाद क्या होता है? Flickbergs. तो क्वेश्चन आ सकता है कि Flickbergs क्या होते हैं? What are Flickbergs? So these Flickbergs are basically large rocky mountains. Okay. So drumlins हमने डिस्कस नहीं किया. Drumlins basically depositional feature में भी आते हैं, तो उसको हम बाद में डिस्कस करेंगे depositional landforms में. Alright. And these are also erosional features. So rock drumlins and your rocky mountains are similar in fashion, although rock drumlins are your type of depositional features. All right, so these are glacial valleys, U-shaped valleys. So this was all about erosional landforms. And one more thing I want to clear that फर्न जो हमने डिस्कस किया था, आइस फर्न को हम नेवी भी बोलते हैं. ओके, नेवे. तो क्वेश्चन आ सकता है कि व्हाट इज नेवे. ओके, देन देयर इज बर्गश्रंड इज अ ह्यूज क्रेवास. ठीक है, क्रेवास ये क्या होते हैं? फ्रैक्चर्स होते हैं, राइट? क्रेवासेस ऑन द टॉप ऑफ द ग्लेशियर, डीप फ्रैक्चर्स आर देयर. और बर्गश्रंड क्या होते हैं? हेड, मतलब ये जो आपका यहाँ पे आपका क्या बनेगा? सर्क बनेगा एक तरीके का. तो सर्क के पास में एक जो लार्ज डीप फ्रैक्चर रहता है, लार्ज डीप क्रेवास रहता है, उसको हम बोलते हैं बर्गश्रंड. ओके, ओके, सो दिस वाज ऑल अबाउट इरोशनल लैंडफॉर्म्स. आगे हम डिस्कस करेंगे डिपोजिशन लैंडफॉर्म्स के बारे में. ऑलराइट, and with this we will discuss all the glacial landforms. So that was it for today's guys. Thank you and subscribe करना ना भूलें अगर आपने सब्सक्राइब नहीं किया है अभी तक. तो till then stay safe, thank you and goodbye.